Okay, our last section for chapter 11, and in fact the last section of the last chapter of the book, our last look at conics, we're talking about hyperbolas. Hyperbolas are so similar to our other friends, the circle and the ellipse. We're going to generalize just one step further. It's only going to require us to introduce the idea of asymptotes and branches, but everything else will feel so similar. So for example, our first goal when we're graphing a hyperbola in standard form, we're going to have the center and the vertices. That's exactly the way we dealt with ellipses. We're going to draw a representative rectangle, but we're not going to put an ellipse inside it. Instead, we're going to connect opposite corners of our representative rectangle with asymptotes. We're going to write the equation of a given hyperbola. We've been doing that for all three of our new conics. And we're going to complete the square to find all of those important things. So let's first look at two cases for a hyperbola. So our first goal is to graph a hyperbola in standard form using the center, vertices, representative rectangle, and asymptotes. So the one thing that changes here, the one difference between a hyperbola and an ellipse, is that one of the terms is negative. So here the y term, in this first example, the y term is negative and the x term is positive. And if you're in that situation, then once you've got your center and your vertices and your representative rectangle, all the things we've been talking about, you then make those diagonal dashed lines. Those are the asymptotes. Now, when the x term is positive, you draw the two branches on the left and the right. So for example, here's the branch on the left side, and there's the branch on the right side. Those don't touch, but they're part of the graph of the same hyperbola. Now similarly, it might be the y term that is positive, in which case we've got a negative attached to the x term. Now in that case, to find the branches that we graph, we have to go up and down. So in this case, our branches are above when we go up and below when we go down. Now this isn't as bad as it sounds at first. I want to point out how you can tell which is which at a glance. Take a look back at that first example. The x term is the positive term, and we get to the branches by going right and left. That is the x direction. So if the x term is positive, we go left and right to get to our branches. That is the x direction. If the y term is positive, as in our second example, then to get to our branches, we go in the y direction. That is up and down. So a nice way to know exactly which branches you've got. And then I'm going to point out that HK is still the center and still found in the exact same way, and A and B are still the horizontal and vertical offsets. Okay, let's go through and graph a hyperbola, and let's first notice that there is a negative term. So that negative means that we are not graphing an ellipse. We're graphing a hyperbola. The x term is positive, so when the time comes, we're going to go left and right, that is the x direction, to get to our two branches. We're going to do exactly what we've been doing, that is using h and k to find our center. H is 3, k is negative 3, so we find our center. X equals 3, y equals negative 3. Then we use our offsets. Let's start with the horizontal offset in the x direction. Downstairs is a 9. That's telling us that a squared is 9. Therefore, a is 3. That's telling us to go 3 units to the right and 3 units to the left to find two of our points for our representative rectangle. Notice I didn't call them vertices because I don't yet want to have to be thinking about whether they're on the hyperbola or not. Now we find our b, that is our vertical offset. B squared is 4, therefore b is 2. We're going to go 2 units up, and we're going to go 2 units down. And with all of that marvelous information, we now have enough in the second pane of this illustration to show the representative rectangle. and then those 4 points that we found by using the offsets. Now, the moment we've got that, some new steps, we then say we need asymptotes. And asymptotes connect opposite corners of the rectangle. Notice they're not going through the 4 points we just found. They're going through the opposite corners where those sides meet. Now, let's go back to this graph and let's remind ourselves this in this equation that we're asked to graph, the x term is positive. So to find our branches, we go left and right. So here's one of our branches, and going to the left and then going to the right, there's the other branch. Now let's talk about why those diagonal dashed lines are called asymptotes. I think you can convince yourself just by looking at this example that that solid line that represents the hyperbola itself, everything else is just a way of us being able to graph it easily. That solid line gets closer and closer to those asymptotes as it goes to the right and the left in this example where the x term is positive. Also, that vertical line at 6, -3, that's tangent again. It just touches down and then takes off again. Same as at 0, -3. So those are the two vertices. We've graphed our first hyperbola. Okay, so another example, and a little bit tricky here. Notice that the y term comes first and the x term comes second. Some people do show hyperbolas in this way when the x term is the negative term. So let's remind ourselves right off the bat that it's the y term that's positive, and it looks like that 25 is not A, that 25 is B. Remember, B is the vertical offset from the y term. And A, we have to look in the second term for that, the x term. A is 2. Now, you might say, what about h and k? Well, those are both 0. The center of this hyperbola is the origin. Okay, so let's graph this. The y term is positive, so it opens up and down. H and k are both 0, so let's select 0 for both of those. A is the horizontal offset, so in this case A is 2. B is the vertical offset, in this case B is 5. So there's our center at the origin, 0, 0. Our representative rectangle, we need that to make the asymptotes. So you can see those diagonal dashed lines serving as our asymptotes, and then the solid lines showing the two branches of the hyperbola. Okay, so our next example, the x term is positive, and that tells us that this will have two branches in the horizontal direction, that is left and right. The h, the x-coordinate of our center, is -2. K, the y-coordinate of our center, is 1. When we look downstairs, these are in the correct order. We see the x term first. So downstairs is a 9. The square root of 9 is 3. So our horizontal offset is 3. And the vertical offset is the square root of 25, or 5. So let's graph this. So this parabola opens right and left, so we'll select that. H is -2, K is +1, the horizontal offset A is 3, the vertical offset B is 5, and there's our hyperbola. The center is shown, the two vertices to the right and the left, the representative rectangle, the asymptotes, and then the two branches going off to the left and the right. Okay, our last example of the entire semester we're going to rewrite in standard form. We're going to graph, we're going to plot the center, the vertices, the representative rectangle, and the asymptotes. So the first thing that I notice here is that -361. It's on the wrong side. It looks like there's linear x and linear y terms, so there's going to be a lot of factoring. We're going to have to factor the -25 out of the x terms, and we're going to have to factor the 16 out of the y terms. So let's do those three things. Notice that we factored out the coefficient of x squared out of the two x terms. We've factored out the coefficient of y squared out of both y terms. And we've got the constant term on the other side of the equal sign. Now we're going to complete the square. M equals 2 for the x's. Half of that is 1. 1 squared is 1. We're going to add 1 on the left side. On the y terms, we've got an m equal to 4. Half of that is 2. 2 squared is 4, so we're going to add 4 over there as well. So there's the first step of completing the square. Now, when we say that we're adding 1 on the left side, we're really adding negative 25 times 1. So we have to add that same amount on the right side. Similarly, when we say that we're adding 4 in the left side, we're really adding 16 times 4 because it's inside of parentheses. So we've got a fair amount of arithmetic to do on the right side. The left side actually will factor using the halves. So when we do the arithmetic on the right, we notice that 1 times 25 is 25, 4 times 16 is 64. Now, inside of parentheses on the left side, we just use the halves. So remember, half of 2 is 1, and that gives us our x plus 1 in the x terms. Half of 4 is 2, and that gives us our y plus 2. This is just completing the squares. Now, we need to do the arithmetic on the right side, and we do that. We learn that that's 400. The way I look at this, I don't worry about the least common multiple of the two coefficients. I just look at the right side and say that this has to be equal to 1. So that 400 has to go. We're going to divide through by 400. Everything's going to be divided by 400, so a little arithmetic kicks in. There's our 1, happy days. On the left side, we notice that the x term is negative. It's the y term that is positive, so our branches are going to be up and down. Then let's look at the denominators. It looks like our a, that is the horizontal offset, is 4, and b, that is our vertical offset, is 5. Okay, so we want a parabola that opens up and down because the y terms are positive. It looks like our center is h equals negative 1, k equals negative 2, and it looks like our horizontal offset a is 4, and our vertical offset b is 5. So there's a graph of our hyperbola. We could move around, we could see a little bit more of it, and we can see all of its properties. Okay, that completes chapter 11, and along with it, the entire book. So congratulations. You've got some homework to do. You can rewatch these videos anytime you like. So good luck on the last midterm and the final.